Hi, I'm Jason Sved.
I'm Austin Ilk.
And I'm Ben Carey. We're here to explore this wonderful beverage. Some of you guys know beer quite well. Others have never had the privilege of tasting a cold beer on a hot day. 7 years ago, it was quite normal for a brewery to use 5 glasses of water to produce just 1 glass of beer. Today we're going to explore how the sustainability of the brewing process has changed from small microbrewers to large breweries. There's no better way to investigate this trend than go inside a local brewery here in Spokane. Okay. Hi guys, we're here at No Lie Brew House in beautiful Spokane, Washington. So let's go inside and check out what's going on. Assistant Brewmaster Damon Scott showed us around No Lie Brewery and discussed the business's sustainable aspects. Mr. Scott received his undergrad in chemistry before earning his master's in brewing and distilling in Scotland. Geographic location of a brewery can play a large role in its overall ecological footprint. Hops and malts must be transported to breweries before the brewing process begins. If a brewery is able to collect local supplies, not only will they save money, but they will pollute less carbon dioxide and associated pollutants from trucking. No Lie finds themselves in an ideal location. They are situated less than 200 miles from Yakima Valley, the largest hop-producing region in the United States, providing 85% of the nation's hops. No Lie is also able to source nearby malts from farms in British Columbia and Vancouver, Washington. Another not often considered aspect of location is the taste of the water.
A lot of brewers consider that local water critical to kind of the character of the beer because it is such a huge ingredient.
No Lie uses Spokane tap water to help achieve some of their unique beer flavors. Also, by bypassing the heavy treatment of water, No Lie is able to save money every batch it brews. It is widely known that beer making is a water-intensive process. Every brewery, regardless of its size, requires a greater volume of water than the volume of beer it produces. Several larger breweries have been successful in reducing the waste-to-beer ratio.
Really efficient breweries are talking, maybe under 3 volumes of water per volume produced. I can guarantee you we're not that efficient.
Anheuser-Busch is one of such breweries near this high efficiency. It met its water efficiency target of 3.5 to 1 in 2012. This ratio was reduced from 5 to 1 in 2007. Their newer process was implemented using a Voyager plant optimization system, which is founded on targeting 5 pillars of any business: quality, maintenance, logistics, people, and management. This more sustainable business structure focuses on more than just economic gain. The shift in focus in the beer community to become more sustainable has caused an explosion of new and more efficient brewing equipment. This technology was more expensive when it was first released.
The biggest gain that we've seen as small brewers is that a lot of the efficient technologies of the larger breweries are making it into smaller breweries just because there's a much larger market for it. And I mean, the huge breweries aren't growing, they're consolidating. So there's a lot of technology out there that companies are building, looking to be able to implement it into smaller systems, just for their own benefit, but also the smaller breweries are benefiting big time from having that technology kind of downsized to our level.
Because they're trying to make. Before breweries can filter their product, larger sediment must be removed. The common process for smaller operations is to settle out this debris by gravity. However, this can take quite some time.
So all of our beers have pretty much a 1-week primary fermentation, and then they get cold conditioned for typically a week. It's between 4 and say another 10 days. And that's mostly just to let everything that's suspended in the beer settle out, so that when we filter it, we're not having to try to filter out a bunch of hot material, protein, haze forming compounds, the yeast.
A quicker and more effective way of accomplishing this is by using a centrifuge.
And what that allows a brewery to do is, as soon as that primary fermentation is done and you've done a short conditioning period, you can now filter that beer way sooner than you could if you're just relying on time and gravity to clarify that product. And that I know has increased breweries' capacity by 30% just by allowing them to reuse the tanks faster. So, that's a way more efficient way. You're not having to buy that much more stainless steel. You're not having to increase your footprint. You're literally just gaining capacity by being able to flip those tanks more often.
Also, the more effective the sediment removal process is, the less frequently filters have to be changed. Anytime there are people working inside for long hours, indoor air quality must be discussed. The concerns for brewers are no different. Large breweries with more capital are able to install expensive high-tech ventilation systems for all of their buildings. However, small microbrewers don't have this luxury and have to take precaution towards certain airborne hazards that come from making beer.
The two big worries for us are CO2. That's something that we have to at least be conscious of, just because it's blowing off of fermentation. And then there's malt dust, so that milling process of the malt creates very fine dust, which, so everyone, when they're milling malt, they have to wear respirators.
There are different ways to save energy throughout the brewing process. One such way that breweries can accomplish this is through capturing lost heat from the boilers.
Huge thing, one of the big things that can help a brewery save water and energy kind of at the same time is after the boil, we boil this for like almost an hour, and so we have to cool 600 plus gallons of water from boiling down to 70 degrees in pretty much less than an hour. So we pass that through a heat exchanger. So we're sending cold city water counterflow to boiling hot wort. So that water picks up a ton of energy, and if you can recapture that water into a separate tank, and then use that for hot side processes, either back into a brew or using it for cleaning, that's probably the easiest way for a small brewery to recapture a lot of that energy and water. Kind of like New Belgium, they're obviously huge compared to us, but they're famous for really implementing heat exchangers throughout their entire brewery to make sure that any heat associated with the process is basically recaptured.
For operations such as No Lie, it is difficult to decipher the energy uses of each step in the beer making process.
We know our total energy consumption just based on utilities, but we don't have the mechanism to really say, okay, when we brew a batch of beer, during that 6 hours, this much energy is being consumed just by that process.
It would be helpful to implement a system that could monitor individual energy consumptions to pinpoint areas that could be greatly improved. An often overlooked step in the brewing process that can reduce waste involves reusing chemicals that are needed to clean.
When we clean a tank, we're putting in a detergent, recirculating that through the tank to get it clean, and that chemical's still good, but if you don't have a way to recapture it, measure the pH, make sure it's still effective in its concentration, then it typically becomes waste. Whereas
No Lie Brewery has 3 local farmers collect leftover malt who use the hydrated grain as feed for pigs and cattle.
Yeah. So we're really fortunate to have farmers that come and just pick it up and get it out of here, because it would be a huge cost to us to dispose of it.
Not only does this save No Lie capital, but the waste is able to fulfill a secondary purpose while also strengthening the local bond that No Lie prides itself in. This closed loop system is one of several ways in which No Lie fulfills the triple bottom line of sustainability. In general, small breweries such as No Lie have a more positive impact on their communities.
The beauty of kind of being inefficient is we've got 6 guys, not including myself or Mark the brewmaster, who are working to create that beer every day. So kind of by inherently being inefficient, just requiring more manual labor, you have more employees. There's probably 6 brewers at the Miller Coors plant in LA, and they're producing 1,000 times plus as much beer as we are now. With the packaged product, it's a billboard, and that's a big reason why we've been incorporating kind of some of the Spokane themes into that, so that it's not just a billboard for us, but it's a billboard for Spokane.
Well, now that the beer's gone, and now that my friends are gone, we think we're done, and we hope you enjoyed the tour of No-Li. We hope you learned some sustainable principles and how they relate to the brewing process, and we want to thank you for joining us today. We'll see you next time.